Hello world, welcome to the Object-Oriented Design video series. In this video, we will be looking into Open-Close Principle. Open-Close Principle states that a class should be open for extension and closed for modification. Now let's try to understand this with an example. In our organization, the payroll class has a public method that calculates the total salary of an employee. And this is how they implemented the method. There is a switch statement on the employee type. Now, if the employee type is full-time, then the total salary would be the sum of basic pay, house rent allowance, and travel allowance. Now, if the employee type is temporary, then the total salary would be a sum of basic pay and house rent allowance. Now, what if the organization introduces a new type of employee called the seasonal employee who is eligible for only basic pay and travel allowance? We might have to add a new switch case for seasonal employees like so. Now, this might not seem like a problem. After all, we just have to add a new case in the switch statement. But consider a case where you have a bunch of classes that has the employee class as a dependency. There might be the employee check in a few of them. Every time you add a new employee type, you might have to hunt down all these classes and make changes in each of them. This can lead to a design smell called rigidity. A system is said to be rigid if it's difficult to implement even small changes in it. Okay, now let's go back to our discussion on open close principle. So our class would require modification every time a new employee type is added to the system. Open close principle states that every change that comes to our system should be an extension rather than modification. Or in other words, for every change that comes to a system, we should be writing a new class or a new standalone function for that matter, rather than modifying existing functions. Now, this behavior can be achieved by using something called polymorphic dispatch, where the concrete type against which a function is invoked is known only in runtime. We will have a much clearer understanding of the concept towards the end of the video. Now, refactoring to polymorphic dispatch involves two steps: abstraction and substitution. The first step of refactoring our code to have polymorphic dispatch would be to make the employee class abstract. You can also consider making an employee interface. For our particular implementation, I'm going with an abstract class. The class name is mentioned in italics to state that it is an abstract class. I also have introduced a new abstract function, the double get total salary function. The method is written in italics and underlined to denote that the method is abstract and has no implementation. The concrete implementation of the get total salary method will be provided by subtypes of the employee. We have the full-time employee class, where the implementation of get total salary returns the sum of basic pay, house rent allowance, and travel allowance. We have the part-time employee class, whose implementation of get total salary returns the sum of basic pay and house rent allowance. The second step to have polymorphic dispatch would require us to refactor our code to support substitution. We can have the calculate total salary method accept an object of type abstract employee class. We can replace the entire switch case with a simple employee.get total salary. If the concrete type of abstract employee is full-time employee, this would call the get total salary method of the full-time employee. If the concrete type of abstract employee is part-time employee, this would call the get total salary method of the part-time employee. That is, the actual method that gets invoked is resolved only at runtime, which, by the way, is the definition of polymorphic dispatch. In fact, we would not even require the method anymore. We can just call employee.getTotalSalary, provided the compile time type of the employee object is abstract employee. Now that we have refactored our code to use an abstract class, we can add more concrete implementations without breaking the existing code. To add a new employee type, let's say seasonal employee, we can just add a new seasonal employee class with the concrete implementation of getTotalSalary method. This implementation is now compliant with the open close principle.